And a wonderful welcome to the second half of re:Invent 2024. We're in the way of your lunch break, so we're going to try to give a lot of cool content. We're going to have some fun with you guys. We are welcome to the modern CI/CD toolbox, strategies for consistency and reliability. Today, we're going to tackle the challenges of scaling CI/CD in a complex environments. And for that, we're going to try to share some actual insights for you guys that you can take away and that you can use in your own organization when you're going there. At least two of us are wearing some cool hats because we believe that we are real builders, and that's what we want you guys to be as well if you leave this session. So the problem that we're going to tackle today is that we see a lot of organizations talking a lot about CI/CD and trying to implement that, and they struggle with that. We are here to change that. We're here to empower you to take your CI/CD best practices to the next level, tuning discussions into action. Unlock the power of the full potential of CI/CD for consistency, security, and spend and software delivery. And for that, I'm here not alone. I'm here with two friends of mine, both of them being heroes, and I'm going to be trying to pronounce Gunnar's name very right. Gunnar, I know you for like 3 years, maybe 4 years, when you got to know you did a game day thing that was really fun. You were the first one to trust me to go onto a live stream, so this was kind of very important for me. Unfortunately, you took a wrong choice in your career because you were a hero before, and then you switched to the AWS side of the fence, which is when you use the hero status, and Torsten is going to explain a little bit about that. But I'm really glad to be on stage with you today.
Thank you so much. Yes, and we also have Torsten with us. And Torsten is, just like Johannes, an AWS hero, DevTools hero, both of them. And I don't know, it feels like Torsten has been around for ages in the Heroes program. So super excited to be on stage with both of you today.
Yeah, and we also have Johannes here. He's also a DevTools hero, as Gunnar mentioned, and he's most famous for playing game days without a laptop. So he went to a game day and forgot his laptop, and he organized the team. But he just distracted others, which was also helpful for
But it was fun, you know?
So, and he's doing a lot of CI/CD stuff on YouTube. So, and it was already mentioned, the Heroes program. So what is this? We already got a shout out yesterday on Matt Garman's keynote, so thanks for that. The Heroes program is a recognition program by AWS to recognize people that do a lot in the community, and we're happy to do that, and we are glad to be on stage with current heroes and former heroes. We're going to talk about a lot today, so be prepared for a wild ride through the CI/CD landscape. Because of that, I will not read every point. I will just directly hand it over to Johannes to take the first part.
Yes, and I'm happy to kind of level set what you guys are going to hear about today. So let's try to define a little bit what CI/CD is and how we're looking at CI/CD. So for me, CI is continuous integration. It starts on the left-hand side of your development lifecycle. That's the way that I look at it. It's your developers working on code, putting something in a potentially Git environment, and then performing unit tests, potentially integration tests, security scans, and at the end, the CI portion creates a deployable and immutable artifact that you then are going to take and going to put that somewhere in your potentially production environments if everything goes well. You start from source control, move over to build and test. You then go to a staging environment, and then you end up in production. We're doing a slight differentiation here between continuous delivery and deployment. Continuous delivery being for us a manual approval right before you go to production needs to be taken. Continuous deployment being an automated process that takes you all the way to production. We'll look later at using feature flags as part of that process because actually if you do continuous deployment, you don't want all of your code directly to land in production. And Gunnar is going to show a little bit on how that actually works and how you implement that within your organization. Now, what is that thing that we bring through that pipeline if we start? Can it be a code change, a configuration change? Let's look at that in some more details, and I'm going to hand over to Torsten to talk about a new look at changes and looking at bringing water through that pipeline that we just looked at.
Thanks. So yeah, as Johannes mentioned, there's a new look at changes that I want to propose, because currently I see the challenges that we have a lot of different pipelines and processes to do our changes. So there's configuration changes, somebody changing a password, changing the port of a database. We have infrastructure changes like provisioning new security groups. And we have application changes like changing our containers or Lambda code. And all of these are separate processes with all the fragmentation that leads to inconsistent processes, increased risk of errors, deploying one change but not the other at the same time, fragmented audit trails where nobody knows why something changed and when and by whom. So that's exactly the problems that we have. I think the dream would be having one pipeline doing all of that, no matter if it's config, infrastructure, or application. Then we know who did the change, we know exactly when it happened, we can enforce all the policies at the same time, and we ensure that we're compliant all at the same time and consistent. So what does it mean? What should be version controlled? And I think version control should be for application code, for configuration, for infrastructure, and now, well, nobody is screaming for secrets. And how do we do that? Because that sounds very scary. We encrypt them. So we are version controlling encrypted secrets. And by that, by definition, they are not secret anymore because they're now encrypted. And now we know who changed them, when, and why. We have audit control, we have change. Also, that means, and some people might hate me for that, we do not do automatic secret rotation. Because then we have no idea when it changed, and we're back to something broke. Did somebody change something? No. And that's something we don't want to have. So I think we want to version control everything. We want to know exactly the changes that are happening. And we want to have them atomic. So there's one change, no matter what part of the application is targeted by the change. And we have one way to roll back all this in a consistent way. So we're rolling back all types of changes consistently. So to sum this up, one version control method for all our changes, an integrated approval process no matter what we change, testing at the same point in time for all the changes, a unified deployment and rollback, and obviously we should improve this process all the time. But if we're now moving everything to one pipeline, into one type of change, we need to make sure that some things keep staying secure. And that's what Gunnar will tell us about, how we do code signing and attestation.
So if we're treating everything as code and we are pushing it through pipelines, we're still not aligned entirely there, I think. We need to make sure that what we're actually pushing through that pipeline is secure. And that's where code signing and attestation comes in. And code signing, well, it verifies that the code hasn't been altered, while artifact attestation, it ensures that the software artifacts, that they remain unchanged and that they're authentic. So it then provides that integrity and the authenticity and the security for both the code and the actual artifacts that are created through our pipeline. So why then do we want to sign every commit? Well, it ensures that we have that verifiable history of changes and it provides protection. So we know that things hasn't been tampered with. So each signed commit, it will then guarantee that authenticity of the change. It ensures that no one has been able to tamper with that code. And more importantly, we have that auditable trace, so we can see every record, and we can make sure that everything is what it says it is. There are obviously a bunch of different security benefits using both code signing and attestation. Because it then provides or prevents us from having unauthorized code changes. So when a developer, an engineer, someone is pushing something to our pipeline or to our Git repository, they sign that code so we know who's actually done it. And then that artifact, if it is a verified code that we pushed, well, it will be built, and then we attestate that artifact so that we know what that artifact is. And then we're able to verify the signature and the attestation so that we know we trust the code and we trust that artifact. And these practices, then they cover a lot of things, but this obviously doesn't remove all of the other security practices that we already have in place. So for instance, this will help us cover supply chain attacks. It will help us cover against tampering of the code or the artifacts. And it will help us make sure that no unauthorized changes are happening. But it doesn't cover everything, and that's where the other security practices come in. It doesn't protect us against the vulnerabilities we might have in the code I've written or Torsten has written, or perhaps a package that we're using in our JavaScript code, for instance. It also doesn't cover that Johannes might have a post-it note with his password on, because then someone could actually sign as him. And it doesn't cover different type of runtime attacks as well. So it should always be used together with other practices. So in my opinion, it is vital to use code signing and attestation. But should you use it everywhere, all the time? Well, I guess we go back to the traditional solutions architect answer, and it depends. It really depends. So with that now, we have everything as code. We are treating everything as code, and we're doing it in a secure way. How do we then look at this through the infrastructure lens? So I'm going to hand it over to Johannes to talk a bit about GitOps.
Yeah, and I kind of forced this topic into this presentation because I've been doing GitOps for the last 6 months of my career, or maybe 8 months, maybe 12 months. I can't remember. It's been so long. Let's try to define what GitOps means, and then let's try to look at where we can apply that in our modern CI/CD pipeline. So GitOps for me means Git and operations. That's kind of easy. That's what everyone believes in it. It combines what Gunnar and Torsten were talking about. Everything that you do is code. Application code, infrastructure code, target deployment code. That means all of your infrastructure components are also part of the code that you need to push in somewhere. GitOps is very famous in the Kubernetes space, especially because on the Kubernetes side, you can apply resource changes very fast using tools like Argo CD, Flux, all of that kind of stuff. Really helps you to make sure that the state of your infrastructure as code is the same as the state of the infrastructure, how it has been deployed. For me, the most important part in that is it empowers developers, people that are very close to the deployment decision, to take that decision. Because the moment that you push something to the Git repository, the moment that someone approves the pull request, in that single moment, a tool takes care to roll out the changes to different web environments. How does it look like if we look at the pipeline? Without GitOps previously, developer was pushing code, it went into source control, someone approved the pull request, it went into the main branch, it runs through all of the CI part, gets tested, security validated. It gets into the CD part where it potentially gets deployed to a staging environment and is going to be tested over there. And that, then at the very late step, there is something before going to production that we call manual approval. Change advisory boards. I think a lot of you guys heard about that in your career. That means you get 20 people in the room. Out of them, 18 people are managers. They don't understand the change that you're actually trying to push. But they take the decision, are you able to go to production, yes or no? That's what we want to change, right? We need to make sure that we put in the developer into the position of taking that deployment decision. That means the moment that Torsten approves my pull request on one of the projects that we're working on, that we're going to hear about later, that moment it gets directly built. There is a new release package built, and essentially it's also going to be available for all of you to use. He's the one that understands the code. He's the one that takes the decision if what I did is good enough to go to production, yes or no. So it empowers builders that are responsible for these kind of things and to take the decision on what goes to production and when it goes to production. Now, as I said, GitOps is very famous in the Kubernetes space. I've been working on that a lot. If we look at GitOps in the AWS land, this is how I called it, I think we have some work to do, and I'm so glad that I can talk about that openly in this case. We have AWS CloudFormation Git sync. That's your first starting point if you want to do GitOps. That means you can connect CloudFormation to your source control, and then CloudFormation is going to be responsible for keeping up to date what you actually just delivered as code. As a second option, we have Code Pipeline V2, also announced earlier this year in 2024. You have the possibility to also connect Code Pipeline to branches right now. That empowers you to do a lot of more CI/CD best practices that you want to do. So check that one out. That also helps you a lot. Then Code Catalyst is around as well, where you can then also build your own CI/CD pipelines to then build on changes on that. And then last but not least, a project that I've been interacting with a lot. It comes from the Kubernetes space, but it can help you to experiment and try out GitOps on your local environment. It's called Canoe. You're going to have a link at the end of the presentation to all of the resources that we are mentioning here. So this supports you in building up your own GitOps pipeline roundabout on your own environment, which you can then take to production. Now, we are in 2024, and everything is talking a little bit about Gen AI, and we wanted to look a little bit into how can you maybe potentially use generative and AI to empower you a little bit better to take deployment decisions. Around about a year ago, so it's kind of old news what I'm telling, a friend of mine, also an AWS community builder, Matt Martz, wrote a blog post around how you can use Amazon Bedrock to empower your deployment decisions. He actually open sourced that, and he made that available for you to have a look at the end. What does it do? In his case, the developer checks in something into version control. I think he's championing this in GitHub, but you can also obviously do that in GitLab with the announced partnership yesterday. It then triggers an API gateway at the background, which then at the end is going to trigger a step function. This step function is then going to be integrated with Bedrock. It's going to go back to your source control provider. It's going to aggregate all of the information that you have, and it's going to send all of those commit messages and the code changes potentially within the context of that Bedrock code. This one is then going to draft a release summary for me. That means I did a code change, 500 files changed. Torsten doesn't know what it is about. It gets to Torsten, but Torsten only reads the 10 lines of summary. With some description of what has been changed. Ideally, also, the LLM is going to empower Torsten to know what's the impact of the change. This information ideally gets to him to Slack. In the stuff that Matt built, it gets to a Slack bot. That Slack bot shows you that summary. You get an approve or deny, and Torsten doesn't need to leave the Slack message. The Slack system itself, he can just click on approve. That goes back to the API gateway, which then automatically releases the pull request. That's the ideal scenario. I think that in 2024, there's still a lot of work to do to empower us developers to really get generative AI into the workflows, right? We have been looking a lot at having that in the coding space, but maybe the next year is going to help us to move a little bit farther than that and really empower us to save some of the times that we're actually having. And what I'm dreaming of is also, if Gunnar took a decision of me doing a change, then next time I don't want this decision to be going to Gunnar anymore, right? I want the LLM model to understand what the changes were, and based on that, help me to take a decision in an automated fashion. That means that we need to trust those models. That means that we need to work a little bit more on how to integrate that within our development lifecycle. Now, all of the deployment stuff that we talked about somehow always built under the assumption that it goes to a production environment. Now, this is not that easy. So in the next part of our presentation, we're going to look at deployment strategies, and Gunnar is going to help us to understand the basics on how we actually look at those.
So I think most of you probably are familiar with deployment strategies, but we still want to cover it a bit so everyone is kind of on the same level around it. Because we're talking about making decisions, well, moving it to the left, but to do that, we obviously need to make sure that in the end, when we actually do that deployment, that when the developer makes the decision to push something that will in the end make a deployment, we need to make sure that we are doing that in a thought-through way. And there are a few different ways of doing these, but why does it really matter then? Well, it helps us to ensure that we have the speed, that we have the consistency, and that we have as little risk as possible when we are doing this. Because if you, as a developer, are empowered to actually push things that in the end will go to production, you need to make sure that you can do it quickly, and you should be able to do it in the same way over and over again, and it shouldn't really be any risk with doing these. So let's look at a few different examples of deployment strategies that we could use. One is what we call the rolling deployment. And this is basically where in this case, we're updating instances incrementally. So we are replacing one instance at a time. In this case, it is instances, but this could be other types of targets as well. And the targets can be 3, they can be 5, they can be hundreds, or they can even be thousands of different targets that you are incrementally replacing this way, moving from an old version to a new version. And what this does is that it makes sure that you have continuous availability of whatever that service is that you're deploying to, because you are continuously getting that new version out to users. And this is very well suited for the type of applications that need to have continuous availability. But perhaps you don't want to have twice the amount of resources, so as you're pushing something new, you are removing something old. Another one is the blue-green deployment type, and this is where we set up 2 identical environments. Once again, I'm using instances as an example, but this could be other types of targets as well, where the blue version is the old version of the code, and then you have the green version, which is the new version. And then you are starting to shift over traffic to that new version once you have made sure that it is working as intended. And you should do that through different type of testing, making sure that the new environment is working. And then as soon as you have it validated, you can switch traffic to that new version. So a simple switch. The old version is still there until you have said, okay, the new environment is working as intended. And that should be done through different types of monitoring and testing as well. So this is great to have that zero downtime again. And it enables you to do a very quick rollback if something goes wrong in the deployment. But it also means that you will have twice the amount of resources up and running. And depending on your service choice, well, that could mean that it is a higher cost. Then we have what we call a canary deployment, which in the same way means that you have an old version and a new version. But then you start releasing that new version to users in using a small subset. And who are those new users? Well, it could be based on perhaps where they are geographically, so we're rolling out to German users, or it could be that we are rolling it out to users that are in the beta program of your new service, and so on. But then, over time, you're monitoring those new users and making sure that the new version works as intended, and then gradually you increase that. And that could be percentage-wise per minute, or 10 minutes, or hours, depending on what you're rolling out. And this is great for detecting issues early in your deployment, meaning that you have number of users using that new version, and you can detect if there are issues with the new code or the new version. So what's important with all of these is that you have some way of monitoring your deployments, and you need to have a way to doing automatic rollbacks. With all of these different options, you should be able to then detect these issues. So you need to have some sort of real-time monitoring in place to be able to detect these failures, and you need to be able to separate between the users that are using the new service or the old service. And then the rollback mechanism, you need to make sure that the services you're using for deployment, that they actually have a way of rolling back. And we know that a part of the tricky part, perhaps, with this is obviously with data. So when you're deploying new versions and you need to make changes to your data store, whatever that might be, it is something to really think about to make sure that when you're doing the rollback, that the data is actually being able to use that old version again. So having these fast rollbacks, it means that you can have minimal user impact. And that's really what all of this is about, making sure that users are happy. Happy users is my favorite thing with the deployments. So what happens then when we've done this? Something perhaps looked good, but it takes a bit of time. It's a bit of a spoiler that I switched the slide, but just play along. You haven't seen this. So we've deployed the new version. Things look good, but after a while, something comes up. Torsten is on call, and he knows how to fix it. So he's starting to log into the AWS console or into EC2 instances and make changes. So he fixes the error. Well, what happens is, and now I'm clicking, so now you can see it. We get drift in our environment. And how do we deal with drift then, Johannes?
Yeah, and I think that's where I come in. where I want to talk a little bit about what drift actually is and how we actually tackle that. And to be honest, I think this is the most controversial part of this conversation, at least from my perspective. Going back to the pipeline, we have someone checking in code. Code lands in the source control. It goes through the CI/CD pipeline. Everything is automated. We have implemented all of the best practices that Gunnar and Torsten have been talking about and that I've been talking about. Everything is code, and we reach a target infrastructure state. But it's 2 a.m. in the morning, and we have a downtime for all of our customers. That's essentially really bad. We need to fix that. And obviously, because Torsten has been in the Heroes program for 8 or more years, he has all of the power to do all of the changes in all of our environments. Let's assume it's the website of a booster club that we have in Germany. He's going to fix that website. He's going to change something that's going to call out. And that's what we call drift. The moment that Torsten does a change that does not actually go through the CI/CD pipeline, the moment that he implements any kind of manual change, and this includes a change of a secret, it includes a change of a configuration, as Torsten has been explaining a bit earlier, in that moment we get into having drift. In the Kubernetes space, once again, this is something that happens pretty often because usually developers get access to the Kubernetes API. They just update some CRDs. kubectl apply is the easiest thing to do that. Obviously, if you have access to that in the AWS console, you also can do the same thing. Sometimes this might be required. But if you're really honest, every time that you do that, every time that you do a manual change in your environment, it creates a single big mess. You want to avoid that. You don't want to give people the possibility to actually perform changes and to actually go into the environment and do something. I need to say, in my organization, we still have that, right? But we're trying to go away from that. What's a better approach, or what's something that I'm advocating for? Ideally, developers get read-only access only to production environments. So if we are dreaming that DevOps, full stack engineer dream where the DevOps team owns everything from the source code up to production, this is how we manage AWS services as well. If we're dreaming that dream, everyone should also be responsible for managing your software when it runs in a production environment. Still, in that situation, I don't want developers to be able to do changes in any kind of thing in their environment. Rather, I want to be able to implement something that I call the break class pipeline that gives me the possibility to deploy changes through the pipeline, but a little bit faster. Think of a pipeline that avoids some of the integration tests, that avoids some of the unit tests. In this case, the change that we're doing is really going to only recover the service, potentially is only going to roll back something that we did before. It should then give us a possibility to roll that out within potentially seconds, because that would recover our service, would make our website available again. It might remove some of the verifications that we need to do afterwards, but the size of the change that we get through that needs to be very small. Obviously, also when using that pipeline, we need to integrate with the deployment strategies that Gunnar was talking about. So we have a deployment strategy, the pipeline will follow that, even if it's a faster version of it. And even if it runs things a little bit faster through than our usual pipeline that has additional verification steps. Could be just disabling a feature flag. It could be just directly deploying to production and not going through staging or stuff like that. Because if you give developers the chance to do changes, you can never be 100% sure that everything that you have in your production environment is really working. I'm going to try to give you an example. In the past 6 weeks, my team has been in my organization working on a new service that we have been building. And we want to run this service into a development environment, then a staging, and then a production environment. Yeah, well, development was up and running, and we were sure that we did kind of no manual changes, but we had possibility to do that. How long do you think it took us to actually go into the staging environment with the infrastructure as code? I told my managers and my stakeholders, it's going to take us 4 hours. It took us 2 weeks. Why? Because on the development environment, we had people actually performing manual changes on the stuff that we are doing. That was a real pain because we kind of did not deliver against the deadline. Just happened 2 months ago. I'm still with the organization, but that's really a problem that you want to tackle if you're looking at that. Possible strategies on how to detect drift. I think it's hard. You want to really avoid that, but sometimes it happens. CloudFormation has a drift detection. The ones that have used it before know that it sometimes works, sometimes it doesn't. There is resources that are covered, there's others that aren't. So I would say it's like an 80% guess. You can implement alerts on using AWS CloudTrail to ensure that if a change is done to your infrastructure that is not coming from the CI/CD user, you can get an alert that at least you kind of get to know. If you're using Terraform, you can save and backup and watch the Terraform state file. Potentially, we can use generative AI going forward to be able to do that. But to be honest, if you ask me, I would really want to encourage you to remove admin access or power user access or change access to the production environments to all of your developers. I know that's going to be a pain. It's going to take longer to implement changes at start, but it will make you faster as you go through it. Now, if you're using pipelines to roll out changes to all of your environments, it's very important that you're aware of the concept of having a pipeline that is consistent in itself, that has all of the building blocks to empower your developers to do right decisions. We're going to look with Thorsten a little bit at what does pipeline consistency mean and how do we approach that?
Thanks. Yes, what does it mean? So now we talked about how this pipeline should look like. So we have a very cool pipeline. It might contain a lot of different ways for break glass pipelines, something we will hear later, all the different steps, all the steps we need for all the stages, and all the checks we want to have. But then we are thinking about several years back, we were told everything should be microservices. So in reality, it just doesn't look like that. But it more looks like something like that, or that, and you get a lot more services, and they're all different. So maybe we need a way to make this consistent, that all our services use the same version. So what we don't want to have is everything the same, but also we want to be flexible to use what we need in our service, but it shouldn't be the Wild West. So we want pipeline templates, some kind of hooks where, like, we have the same style of things. So if you onboard people to a project, or people moving from one service to another, understand what's going on, because, yeah, that looks familiar. That's like in service 1. Now in service 2, it looks familiar. Oh, yeah, there are some changes. I can understand them. And you want to have people and teams be able to adapt these pipelines to new requirements very fast. Like, you just need to copy that part of YAML. Like, oh, yeah, but my pipeline looks totally different. This doesn't work there. So you want to have organizational standards, how that works. You want to enforce them. Everything needs to go a certain container scanning step or secrets scanning. You want to enforce some things, but still give some freedom to people. And that's, how do you do that? And we have two approaches there. We have a centralized one where a dedicated team is maintaining your pipeline. There's a centralized pipeline, you include it in every repository, and that's how it's done. It definitely ensures consistency, but it's very unflexible, and there's one team that needs to implement all the changes you want. And there will be constant complaints about they're too slow, they're too slow, they're too slow. On the other hand, every team builds their own pipeline, however they want. That's very flexible. But I say it risks inconsistency, but I would say it guarantees inconsistencies. There will be some teams that don't do the container scanning. There will be teams that do a different type of rollback. There will be things that change completely the thing, how they work. So what I'm advocating for is a mixed approach, like having a dedicated team providing extendable templates and constructs. So if you heard my name before, I'm very active in the CDK space, so that's why I'm coming from this constructs approach. Model your business logic in a construct and say, this is how we want it to behave. The technical implementation comes later, but this is how we want it to behave. And a dedicated team is defining what steps should happen. And then the teams are responsible for updating their pipelines to the latest version, what they're mandated by the centralized team. But they are responsible for updating and also for fixing their pipeline. Because nothing is worse than another team breaking your pipeline, and you're responsible for fixing it, but they broke it. So you want to be the ones responsible for breaking it also. And this allows flexibility, and it powers you to have whatever you want, but still meeting these standards and guidelines and rules of your company, of your enterprise, of your open source project, whatever you're doing. So this is a project. There's a technical solution to that. We will be talking later this presentation with another topic, but it will involve both parts. And now we always talked about these types of changes and different pipelines and all things. But now we're coming to another thing that might help us. Maybe we want to decouple change and deployment. And that's something Gunnar will tell us.
That is correct, Torsten. That was a great handover, so I like that one. So I'm not going to shame anyone in this room, because that would be awful. But if I were to ask you how many of you had put the URL to an API within your code, or perhaps put the setting for debugging within your code, I think many of you would probably raise your hands. I know I would, because that's an easy way to do things, basically. But what I want to talk about is, like Torsten said, how we can move some of those changes, and also the way we're actually giving things to users away from the deployment. So we don't have to actually deploy for every little change. The pipelines that we've talked about, well, they can look very different, but it's basically this. We have the source, we have an artifact, we build and test, and then in the end we deploy something. But we want to move from having that just deployment way of thinking. We want to move to a release way of thinking, which comes after the deployment. Because in traditional practices, the deployments and the releases were tightly coupled. I wrote code, I pushed it to Git, it went through my pipeline, and users were able to use that new version. We want to decouple it so that the release part, users starting to actually use it, that comes later and can be controlled differently. Because this approach, it will then reduce risk. It will enable us to safer do testing in production. And it also sets the stage for doing dynamic feature management using what we call continuous configuration. And that's a wow moment, I think. Because you've heard about continuous integration, you've heard about continuous deployment. Well, I want to add CC, which is continuous configuration. And this enables us to do dynamic adjustments to how an application behaves without needing to redeploy code. I could also probably ask how many of you have stayed up on Thursday evening to do a deployment because you need something to be in production at 9 p.m. And there's probably a bunch of you who've done that as well, because that was the traditional approach. You timed your deployment to when users needed that. But we want to move away from that way of thinking. So this allows us to then release updated configuration without actually deploying things. So this allows us to then turn a feature on and off for users. It allows us to tune operations. That could be doing toggling of certain things, or it can be how we're throttling or how we're enabling logging in different levels by having that as a separate thing besides our code. And this also allows us to limit the area of impact for any type of change that we're making. All of this then happens without deploying new code or without restarting your application. So combining this continuous configuration approach with feature flags, it becomes a super powerful tool for us to be able to toggle features, conduct experiments, and it limits the impact of these changes. So let's look at an example. You remember Canary from our deployment strategies. We can use the Canary release approach with feature flags as well. So we can deploy a new feature to a limited audience before rolling it out to everyone. This is separate. We've already deployed using our deployment strategies, so the new code is already in production. This is just enabling that feature for users. So we start deploying it to Canary Group 1. Canary Group 1, once again, it's the Germans. So they start using that new feature, and we can see if it works. And then we can monitor for issues when they're actually using it. Still the same code base for all users, it's just that the feature is enabled for one group. And then over time, we start releasing it to more and more users. This allows us to even earlier detect these bugs or issues that we might have in our applications. Because we've already done the deployment, we already have the code in production. I don't have to be there Thursday, 9 p.m. to actually press the deployment button. And this allows us to then have safeguards in place. Because once again, we should monitor this. We should make sure that we can roll back if needed as well. Just disable that feature again for users. So the results then, if we are starting to use this approach, is that we can quickly disable different type of problematic features without having any real impact. It allows us to validate these changes in our production environments using real-world data. So we have this, everything is deployed in production, and we can roll it out in a month or in 2 months, and so on. We know that things are working as intended already. And it allows us to then deploy faster because we're separating these feature releases from the actual code deployment. So we can do new releases more frequently. And it allows us to test different features more safely as well, because we can do very targeted rollouts to specific user groups, or it could be using A/B experiments, where we're rolling out a feature, then measuring the impact of it, or seeing how successful the new feature is, basically. So using feature flags as part of your continuous configuration, it means that you're able to do a lot more in a much more safe way. And I know many of you might be thinking, well, we already have environment variables. We're putting our configuration there, or we're putting it in a DynamoDB table. And that's great. You're one step towards this, but you should take it even further. We're back to those pipelines that Torsten was talking about, where we have configuration as a pipeline. So we're pushing these through pipelines, following these types of deployment strategies as well, but in this case for configuration or for features. So now then, we have our pipeline. We have decided that we're using service X and we're using service Y and we're doing it in a specific way. Isn't it easy to get stuck using it in a specific way, Torsten?
Yes, it is, and there's a way out.
Thank you. That's good.
So we're talking about vendor lock-in, and it's not about AWS. You have your configurations, your features, and all the things. Everything is working on one CI/CD platform. And then you become dependent on your actions, on your steps, on your pipelines, on whatever you're building. But then, at some point, what do we do if for any reason, like, for example, AWS announcing a cool feature and collaboration with GitLab, or as Gunnar pointed out, we're from Germany, so maybe there's regulation changes, and we need to use another vendor that adheres to these regulations. So how do we change our CI/CD vendor? So what we want is a portable and flexible CI/CD. We want to have our idea of our pipeline, of our definition of our pipeline, being independent from the tooling. And we want to use the best of class for everything. So maybe today we want to scan with solution X for problems in our container images. Tomorrow, it's feature Y. And we want to have this consistency that I was already talking about earlier. So it should be future-proof and easy for adoption. And that's where we're coming in with the tooling that Johannes also mentioned, that he's doing changes, I'm reviewing them. It's about Progen pipelines. Progen pipelines is a tool. It's an open source tool. You can just find it on npm.js, so it's a TypeScript project, where you define your application's pipelines. We're starting with CDK pipelines. I mentioned my favorite tooling right now and before, but we're extending that to other tools. So you're defining your pipelines as constructs. as business users. You say, I want to have a GitHub CDK pipeline. And this is the stages that I want to have. I want to have a dev stage in this account. I want to have a production stage there. And then I want to add a lot of steps. I want to have container scanning enabled. I want to have that, and that, and that. And then somebody comes in. There's this new cool collaboration with GitLab. We're moving. Like, yeah, that's not a problem. Let's just use a GitLab CDK pipeline with the same configuration. It's the same. It's just another class name. And now it renders to a whole new set of files. So when we look back, it was a whole lot of GitHub Action YAML. Now it's a GitLab CI YAML. This is because we're defining our pipeline from a use case perspective, and not from an implementation detail. So we're not juggling YAML files. We're talking, this is what we want to have. And that's what we can use for what I explained earlier with the consistency, because we can centrally define what happens in that pipeline, but we can still give teams these hooks to change the behavior using properties on this construct. But the rendering and the implementation details are up to somebody else. So what's in the box of this tool? It's you're defining your CI/CD pipelines in TypeScript. There's abstracted concepts like I want to log into Harbor, for example, or Artifactory. I want to use Sneak or Trivy or Inspector to scan things. This is abstracted constructs and tasks. And I select them. But how they're implemented on the CI/CD tool, that's up to the implementation of this step. Currently, it supports GitHub, GitLab, and AWS tooling. But we're open to pull requests. It's an open source project. So the idea is define your pipeline logic, build platform agnostic constructs, implement your own tasks that you want to have, and then generate your pipeline from that source in your repository. At any time, you can just eject and say, yeah, I have the rendered YAML files in my repository. I just don't want to use that tool anymore. I have the rendered file here. I can just start using that. You shouldn't do it while using the tool, because then we're back to Drift. And then gradually migrate to these pipelines from one project to the next, extending your constructs as you need them to be changed. That brings us to Gunnar. Wrap him up, what we talked about.
Still wrap up. All right, so we've covered a bunch of different things in this session. So I just wanted to give you a bit of a key takeaways from this session. So automation is really foundational when we're talking modern CI/CD. By automating your deployment pipelines, you can remove a lot of the manual errors that we might otherwise have, but it also allows you, obviously, to speed up your processes. So you can make sure that you have consistency across your every deployment. And make sure to look at using code signing and attestation, because that helps you to ensure that you have authenticity and that you have integrity in all the changes. And like I said, should you implement it everywhere? Well, that is up to you to look at if you really need to have that in each and every project or service and so on. Make sure that you have proper rollback strategies. And this doesn't matter if it's just for the deployment or if it's for the continuous configuration. Whatever you are doing, you should make sure that you know how to do a rollback. Because if there's one thing we do know, it is that eventually things are going to fail, and then you need to know how to do that rollback. Because that helps you tend to have faster recovery, and it also reduces the downtime that you might have. And every now and then, things might drift. I know Torsten wants us to block all the access to environments, and that is the goal. I think many of us are very far from being there. So drift does happen. So look at how can you detect drift in your environments so you can maintain that consistency within your infrastructure and within your applications. And it depends on how you're deploying today. It depends on the services you're using, how to be able to detect drift outside of, for instance, CloudFormation drift detection. Make sure that the pipelines that you're building are standardized, because that helps you as you're growing projects, moving into new projects, but it also helps every engineer, every developer to know how does the deployment work within your company or your organization. Because that also enforces these best practices. So everything we've talked about today makes it easier to roll that out. And that's not really optional in the end. You just have these practices of how you're doing your deployments. And I want to stress that you should be using continuous configuration. And also use that term. I love that term. So keep using continuous configuration. And then make sure that you have feature flags in place, because then you can separate the deployment from actually rolling out things to your users. And that allows you to be very dynamic in how you deploy things and how you make changes in your environments as well. We've gathered a bunch of resources in the QR code you see on screen now, so you can check that out. It brings you to a blog post where we have more reading material that you can use to learn more about all of this. Also, if you're interested, you can join the AWS community. That link will take you to community.aws, and you will be able to sign up and take part in lots and lots of community activities there. And with that, we want to thank you all for joining. I want you to join me.
Of course.
So thank you all very much for joining this session where we've looked at the modern toolbox. Hopefully, you all leave this session with a bunch of new tools in your CI/CD toolbox, and that you'll be able to implement some of these, I don't want to call it best practices, I don't think that's a good term, but some of these practices in your organization.
Yeah, and I'd like to add that it's not that easy, right? So we're standing up here and talking a little bit about what we think is the right thing to do, but we know that it's hard, right? I'd love to talk to you later if you're interested to share with us what is your most common practices, right? That you join us on the Project Pipelines project to be able to make CI/CD something that is automated going forward, right? That you don't really need to think about, make it more convenient for everyone to use. And I think, Thorsten, that's what you also want to do, right? You want to grow that project.
Exactly. And I agree with you, calling it best practices is something that's a bit hard. So that's why, coming back to the CDK topic, they now call it proven defaults. It's not the best way, because we will never know what the best way is, but you know that it's a working way. And it has proven to be a good thing. And that's why I encourage you, just use proven defaults. We know that it works. We encourage you to try it out. Come to us, talk to us, and also try out the tool that we mentioned and ask us with any questions you have, but I think not on stage, because we need to leave the room after that session because the next speaker is lined up, but we will take in questions off stage and in the hallway.
All right.
Before we get going, there's one more thing. One more thing.
One more thing.
This guy works for AWS. AWS is very data-driven. There's a survey in your app that you're going to get. Please fill that out. Gunnar and I, we don't care. Thorsten and I don't care, but Gunnar cares a lot. I'm sorry for that.
He's data-driven.
But he's the guy that needs the survey feedback, so please make sure that at the end you put in that survey. Just take those like 30 seconds. We gave you 5 minutes back. Should give you enough time to do that before you run out. So thank you so much for coming over to the MGM. And thank you to all others on, I think, Caesar's Forum in Mandalay is where we have Simoncast. So hope you enjoyed, and we're here to talk.
Thank you very much.